today, and the discriminant relates back to the quadratic formula, so hopefully it will kind of have some familiarity for you. The roots of the quadratic can be found by using the quadratic formula, which is listed there at the top of your paper, and that is as long as A, B, and C are all rational numbers. But the value underneath the radical, b squared minus 4ac, it tells us what kind of roots and how many roots we can get, roots being x-intercepts. Sometimes we don't have to know the answer to the problem, we just want to know how many answers will we get, or what kind of answers will we get. And that's what the discriminant tells us. And there's actually 4 situations involving the discriminant. And that's what we're going to explore today. As we look at example 1, it says, for each of the following quadratics, calculate its discriminant, its roots, and state the number and the nature of the roots, whether they're rational, irrational, or imaginary. And the first situation is that the discriminant is a perfect square. So I think I kind of glossed over it. I'm going to just go back here. The discriminant is b squared minus 4ac. No radical. And it's in here in the case 1 as well. The discriminant equals b squared minus 4ac. No radical. It's the value underneath the radical. So the first thing that we're going to start with is we're going to say, well, a is 1, b is 3, and c is negative 10. Just like we would with the quadratic formula, and if the quadratic is not set equal to 0, then we need to make sure that it's set equal to 0 to be able to use the discriminant. So we're going to fill this back in, and we end up with 3 squared minus 4 times 1 times negative 10. And the first situation we're looking at is that the discriminant value is going to end up to be a perfect square. Well, 3 squared is 9, and 4 times 1 is 4 times negative 10 is negative 40. And what happens when we get 2 negatives together? We get a positive. So this is going to be 9 plus 40. Our discriminant in this problem is 49. It is a perfect square. Well, what we want to do is we want to figure out, well, how many roots are we going to get and what kind are they going to be? So we can use the quadratic formula to find that. And when we fill in the quadratic formula, some of you might be going like this, it's going to be x equals negative b plus or minus the square root of b squared minus 4ac. But we just figured out what b squared minus 4ac equals. It equals 49. So we're going to take that value and we're going to put it back into our formula. Shorten that up a little bit. All divided by 2 times a. Can we take the square root of 49? Yes. It's 7. So we get negative 3 plus or minus the square root of 7 over 2. And now that we don't have any radicals in there, we can figure out these values. It's going to be negative 3 plus 7 divided by 2. And it's going to be negative 3 minus 7 divided by 2. And worst comes to worst, if you have to type that in, use your fraction button if you have it. Negative 3 plus 7 divided by 2 gives us 2. Or negative 3 minus 7 divided by 2 gives us negative 5. So our values here are 2 and negative 5. If we get the answers 2 and negative 5, is our quadratic factorable? Matthew? Yes. We have a whole number there, and absolutely positively, if we get 2 and they're actually integers, because one of them's positive and one of them's negative, but they're integers that we can actually really see when we look at the picture of the graph, and they work out very nicely when we factor. So ultimately what we can say now is that when the square root of, or when the discriminant is 49, we ended up with 2 answers. And the kind of answers that we worked with, look up here at what our options are rational, irrational, or imaginary. Rational means any number that can be written as a fraction, and certainly 2 and -5 can be written as a fraction. So when the discriminant's a perfect square, we end up with 2 rational answers. If we look at letter B, the second case, the discriminant is not a perfect square. When we look at our equation, x squared minus 6x plus 7 equals 0, good news is it's set equal to 0. We're going to identify a equals 1, b equals -6, c equals 7. And we're going to use our discriminant, b squared minus 4ac, no radical, to calculate. So we're going to get -6 squared minus 4 times 1 times 7. This time what it says is that the discriminant is not a perfect square. If you're typing in -6 squared, you must have parentheses in your calculator. So we get 36 minus 28, and 36 minus 28 is 8. 8 is the discriminant. That number gives us some information without actually having to use the quadratic formula or solve by factoring or solve by graphing. But what we want to do is we want to figure out how many answers and what kind we get. And what we do is we use the discriminant. We're going to go back to the quadratic formula now. It's x equals the opposite of b plus or minus the square root of b squared minus 4ac. We already figured out what b squared minus 4ac equals. It's this value right there of 8, all divided by 2 times a. And I know I kind of chumped you on space in this particular one, but 2 negatives make a positive. And over here, with the square root of 8, we can simplify that value. So when we do that, we're looking at values like 4 times 2 equals 8. And then 4 is 2 times 2. And remember, when we're dealing with this, we need 2 of the same value to take out 1. 2 2's, we can take out 1. So this is going to be 2. We still have a single 2 left, all divided by 2. Well, lastly here, we can simplify this one more time. The 6 and the 2 and the 2 are all even numbers. They're all divisible by 2. We can do 6 divided by 2 is 3. 2 divided by 2 is 1. 2 divided by 2 is 1. It's true, and you're running out of space here, but technically we don't have to write that 1. So this is really 3 plus or minus the square root of 2. And I know, you're running out of space there, so you might just leave that. Is this quadratic factorable when our discriminant is not a perfect square? No. Why not? Because there's still a square root in the answer. That's why not. So no, it's not factorable. But how many answers did we get here? 3 plus or minus the square root of 2. It's 3 plus the square root of 2 and 3 minus the square root of 2. So we're going to get 2 irrational roots. Irrationals cannot be written as a fraction. They're a non-repeating, non-terminating decimal. They're the big long decimals on your calculator. So we've talked about the discriminant as a perfect square. Talked about now the discriminant is not a perfect square. Third situation is what happens when the discriminant equals 0. So, like the others, we start with A is 1, B is negative 10, C is 25. We're going to put these values back into our discriminant, which is b squared minus 4ac. No wrap. So it's going to be negative 10 squared, and if you're typing that in your calculator, you need parentheses. Minus 4 times A times C. And this situation again is that we're going to end up with the discriminant equals 0. Negative 10 squared is 100. And 4 times 1 times 25 is 100. And 100 minus 100 is 0. So our discriminant equals 0. And now what we need to figure out is our roots. So we're going to use the quadratic formula to figure out our roots. So it's going to be x equals the opposite of b. I think you'll have enough space in this one. Plus or minus the square root. But remember, we already did b squared minus 4ac. It's 0. All divided by 2 times a. Well, what's the square root of 0? It's 0. So we've got the opposite of negative 10, which is 10. This is 0. Square root of 0 is still 0. We just don't have to write the radical. Divided by 2. Well, plus or minus 0, we're adding nothing to 10. So this is really just 10 divided by 2, which is 5. So, when the discriminant equals 0, how many answers, how many roots, how many zeros will we get? We only get 1. And what kind is it? Well, we ended up with the number 5 when we solved it. That is a rational number, any number that can be written as a fraction. If we end up with something like the number 5, can we factor? Yes. It's when we get the square root of something that can't be simplified. One last situation here with respect to the discriminant. And this is when the discriminant is less than 0. What does less than 0 mean? Tiffany? It means that we're working with a negative number. So in this case, here we still start off the same. A is 1, B is negative 8, C is 20. Fill these values back in. Negative 8 squared minus 4 times A times C. If you're typing in negative 8 squared, you must have parentheses in your calculator. Negative 8 squared is 64. 4 times 1 times 20 is 80. And 64 minus 80 is negative 16. That is our discriminant. We're going to use that now within our quadratic formula. And our quadratic formula says x equals negative b plus or minus the square root. But remember, we just figured out what b squared minus 4ac equals. It equals negative 16, all divided by 2 times a. If we simplify this a little bit, this is 8, double negative gives us a positive, plus or minus. Can we simplify the square root of negative 16? Got a yes? Tiffany? What's the square root of negative 1? We're going to get an imaginary number. Square root of negative 1 is an I. Square root of 16 is 4. And once again to point out, 8 and 4 and 2 are all even numbers. That means that they're divisible by 2. 8 divided by 2 is 4. 4i divided by 2 is 2i. 2 divided by 2 is 1. We don't necessarily need to write that 1. I'm going to leave it right there like that because that's probably, in terms of your space, all the space that you have here. But our question is how many answers do we get when our answer is something like 4 plus or minus 2i? It's actually 2. 4 plus 2i and 4 minus 2i. And this time, because there's an imaginary in our answer, that's how we categorize that. When we get an imaginary for our x-intercept, is our function factorable? No. You should start thinking about, and I hope it's not going to be memorized, but you may have to memorize some of that. As we flip over here to the back, one more thing that I want to point out here about case 4 especially, and it's not that you haven't heard it before, but now we're taking the time to put it in writing. If we get imaginary roots, we do not have an x-intercept. Our graph does not cross the x-axis. I'll say that one more time. If we get an imaginary root, our graph will not cross the x-axis. No x-intercepts. But as we finish here today, I knew that my time would be a little bit tight. So I actually have things drawn in for us already. I can suggest that you take a couple of minutes after the fact and try to practice graphing these. And what I'm most concerned about is, can you use your calculator to approximate the zeros? That's my question for you, because I have it drawn in for you because we're going to run out of time. Like we did on the front page here, it says by using only the discriminant, determine the number and the nature of the roots. So we're not going to do the quadratic formula here. It's by only using the discriminant. And then we can sketch the function on the grid provided. So when we look at this problem here, we see A is 2, and B is 7, and C is negative 4. So we fill in our discriminant, which is B squared minus 4ac. 7 squared minus 4 times A times C. 7 squared is 7 times 7, which is 49. Minus 4 times 2 is 8, times negative 4 is negative 32. And once again, what happens when we have a double negative? We get positive. So this is positive. And when we add 49 plus 32, we're going to get our discriminant value, which is 81. Now you may have to flip over to the front of your paper here. But the first question is 81 a perfect square? It is a perfect square. So how many roots will we get? We'll get 2. And what kind are they going to be? Are they going to be rational, irrational, imaginary? They're going to be rational. Like I said, I'm not going to take the time to type this into the calculator, but I do have a picture for you, including where the roots are. I know that you can't completely see the root to the right, which is really 0.50. But here's a picture to kind of give you an idea of what things would look like. And it's not even what things would, well, they are. It's exactly on the graph of 2x squared plus 7x minus 4. So there's the picture of that one, including the roots. And that's something that you can spend some time on later on. When we look at B, again, we're using our discriminant. So we need to at least be familiar with the 4 different situations. And as we look at this one, we see that A is 1, and B is -8, and C is 25. We're going to go back into our discriminant. B squared minus 4AC, no radical, and fill that in. B squared minus 4 times A times C. If you're typing in -8 squared in your calculator, you must have parentheses. -8 squared is 64. 4 times 1 times 25 is 100. And 64 minus 100 is -36. Again, you may need to flip your paper over. But how many answers are we going to get when we have a negative for our discriminant? Still going to have 2. And what kind are they going to be? Rational, irrational, imaginary? These are the imaginaries. The picture on this next one is small. Again, you could type this in to your calculator, but because of time, something to notice on here is that my scale here is 10, 20, 30, 40, 50. And once again, when we have imaginary roots, the graph does not cross the x-axis. That's the thing on here. So if you draw your picture, sketch your picture, you just want a quadratic. That's mostly in the first quadrant here. That does not cross the x-axis. Again, you can type that in. You may have to work with the scale of your windows to be able to see the picture. Letter C. Discriminant of 4x squared plus 4x plus 1. Nice, once again, that the equation is set equal to 0. If it's not set equal to 0, we need to make it set equal to 0. But A is 4, and B is 4, and C is 1. And we're going to put those values back into B squared minus 4AC. So it's going to be 4 squared minus 4 times A, 4 times A times C. And when we figure this out, 4 squared is 16 minus 16 means that our discriminant equals 0. We might have to flip our paper over. How many roots will we get when our discriminant is 0? Jordan? 1. Gonna get 1. And he even said it ahead of me. 1 rational. So to get close to finishing here, And before we do, let's look at the picture. Here's our picture where we only crossed the x-axis once. And again, very hard to see the root, but it actually ends up to be negative 5. Again, getting close to finishing here. When we look at letter D, we need to identify what does A equal, what does B equal, what does C equal. A is 4, B is negative 4, C is negative 7. We're going to fill that back into the discriminant of b squared minus 4ac. No radical. Negative 4 squared minus 4 times a times c. Negative 4 squared. If you're typing that in the calculator, you must use parentheses. A 16. 4 times 4 is 16 times negative 7 is negative 112. Double negative gives us positive. And 16 plus 112 gives us our discriminant value of 128. So when we look at this value here, the first question is 128 a perfect square? And it's not. And because it's not, how many answers would we get if we actually figured out what they were? Jordan? So we get 2. What kind are they going to be? They're going to be irrational. And in the effort of time, here's our picture. We get negative 0.914, and we get 1.914. We get non-repeating infinite decimals, but it still does cross the x-axis. It's just not at as, lack of better words, pretty point as some of the others. So to finish here, a multiple choice question. Which of the following discriminants belongs to a parabola with 2 rational x-intercepts? So you know when you're taking a multiple choice test that you always want to see if you can eliminate any of the answers. And the first one that jumps out at me is that it's not going to be 0, because 0 only has 1. And it's not going to be negative 5, because negative 5 is going to have an imaginary. So now we narrow it down to answers A or B, and then we've got a much better odds on getting it correct. Which one is it? Why is it B? Jordan? Because 49 is a perfect square.